So today we're going to be making a simple FM synthesizer, and we're going to start off by creating an ADSR. So I get to start off actually with our input, which is going to be the MLE.midiKey object. And this is going to give us a MIDI note message when I play the keys on my laptop. You can see a velocity of 90 when I push a key down, and a velocity of 0 for note off when I release a key. So we're going to take this information and we're going to do a couple of things. The first thing we're going to do is we're going to unpack it. And I'm going to give this unpack two arguments for two integers, because we get two integers out of MLE.midiKey in our MIDI message. And the left and the right integer, the 0, is going to come out of unpack first. So remember, these are always going to come out right to left. So this value is going to come out, and what we're looking for is looking for 0. So our select object is going to send out a bang right here whenever it receives a 0 message. So if I play a note on, nothing happens. If I release it and play a note off message, this is going to go to 0. We'll see a bang right there. Okay? The other thing this is going to do is anything that's not a 0 is going to come out this side unchanged. So you'll see this is going to say 90, and then this is going to bang. 90 for the velocity 90, and when I release the key, that 0 is going to come out here. So this is going to be my note on message, and this is my note off message. So for an ADSR, the first thing we want to do is we want to make the ADS stage. Remember, the attack, decay, sustain stage. So let's go ahead, since we know that our velocity of a MIDI device is always going to be from 0 to 127, let's scale this number by 127. I'm going to put a period here. This period is going to let this object know it should operate on floating point numbers, and that's going to enable this to be a floating point number, which basically just means a number that's not an integer, right? If for some reason I didn't, so if I just play this note now, you'll see it comes out always as 0.79 depending on the velocity that's coming out of my MLE.midiKey. I can change the velocity, by the way, by using my up and down arrow keys. I'm sorry, my left and right arrow keys on my laptop keyboard. See how the velocity is going up? And it's going to go up to 127. It can't go above 127 because that's the maximum value for a MIDI velocity. Any MIDI value, really, most MIDI values go up to 127. Okay, so if I didn't put a float here, then this is only going to operate on integers, and 90 will always be less than 1, and so it's just going to round it down to 0. If I were to set my velocity all the way up to 127, then 127 divided by 127 is 1, but we'll never get a fractional value. We need a period here in order to make this be a fraction. Okay, so this is going to be our amplitude of our attacks phase. This is a pretty common thing to do, is to scale the attack and the sustain by a velocity, right? So what we're going to do here is we're going to create our little boxes for our attack time, our decay time, and our sustain level, right? And now we can process all this stuff. So we know that our attack time is going to be the first element in any ADSR message. So I'm going to go ahead and I'm going to think about how I'm going to pack these things together real quick. So first of all, I should notice my sustain value really should be a floating point number, because it's going to be an amplitude, whereas these are both times. I'm going to label this as attack, label this as decay. I'm using a comment box, so using the letter C to make a comment box here to label these things, and this is going to be sustain. I'm doing a Command or Control J to make the comment box sort of shrink to fit the text, is what I'm doing there. So I'm going to make a pack object here. And this pack object is going to format a list for our line tilde. So remember, line tilde is always expecting value time pairs, right? Go to X value in Y milliseconds. So we're going to put together a 4-element long value time pair list. So it's going to be a float for a value, an int for a time, a float for a value, and int for a time. When we do that, notice we get 4 inlets here, which we can use to populate those values. Attack is going to go here. Attack is going to go here. Decay is going to go there. Sustain is going to go here, but we're not going to put that in there quite yet. And the value of the maximum value that our attack is going to reach is going to go in here, right? So normally this would just be 1, but we're actually going to scale it by our velocity so we can have a varying peak level of our amplitude envelope. Okay. Let's actually do things slightly differently. Let's actually do it like this. What we're going to do is we're just going to do a bog standard attack decay envelope. And so what that means is I can go ahead and replace this F here with a 1. And all of this stuff can just be the same, and we can just treat this as times. This can go full range from 0 to 1, and this is going to be 1. And then what we'll do is our line tilde here is going to get scaled by our velocity value. All right. So notice I sent this float number into a sig tilde object. That's going to turn this float into a signal, which will be like an audio signal, which is going to work within this line tilde, which is also an audio signal. So whenever you convert back and forth from a control rate object like these with no tildes to an audio rate object like these with tildes, then you might need to pay a little bit of attention to how you do that. And so I'm going to use these sig tilde objects to convert control rate numbers into signal numbers. Sometimes you don't need that, but I'm going to do it every time, or most times, just to be consistent. The other thing I'm going to do here is I'm going to do a trigger. So what this trigger is going to do is it's going to take this number and it's going to do a couple of things in a specific order. It's always going to go from right to left. So the first thing we're going to do is we're going to bang out send out a bang, which is going to trigger this pack object. And the second thing we're going to do, the first thing we're going to do is going to send out this floating point number and then send out the bang. Okay, so whatever this number is going to come in here and replace the F, because this is looking for a floating point number, which this is going to be. It's going to send that floating point number out here to our signal to set our final output scale the output of our line tilde object by our velocity. The second thing we're going to do is we're going to bang to send out this envelope to our line tilde object. I'm going to go ahead and put in some good reasonable values for our attack, decay, and sustain. And then I'm going to prepare this, which is going to be our release time. And our release time can be very simple. I'm going to go ahead and put our release over here. All right, so this is release. And this release time is going to just go to 0 in that amount of time. That's sort of what that message is going to say, right? And we're going to go ahead and store that in the right inlet of this message box, which gets banged on a note off, and this gets sent to our line tilde. So if I play a note, what we should see come out of here is our attack, decay, sustain portion. What we'll see populate this is our, I guess we should actually put in our release time, so say 100 milliseconds. So this is going to say go to 0 in 100 milliseconds, and that's going to get banged when this message gets triggered. So let's just put this right here. We're just going to monitor what's coming out of this pack and this line in this message box. So there's our attack, decay, sustain. Go to 1 in 5 milliseconds, then go to 0.5 in 250 milliseconds. And now when I release it and this bangs, we're going to say go to 0 in 100 milliseconds. And that gets sent to this line tilde object. If we take a look at our scope, we might be able to see this. All right, so we can kind of see that a little bit. So there's our attack, decay, here's our sustain, and here's our release. And there's a 0 value right there. Okay. So now that we've got an attack, decay, sustain envelope, let's go ahead and make our operator, our carrier operator, right? So this is the oscillator we're actually going to listen to. So this is FM synthesis, so we're going to be using a sine wave for this. So this is our cycle tilde object to make a sine wave. And we know that coming out of here is going to be a MIDI note. So we're going to convert that MIDI note to a frequency using the M to F object. And just so we can monitor it, here is a floating point number box for our frequency. And this is going to set the frequency of our sine wave. And then we can just have an output volume control of 0.1, our DAC, easy DAC for our DAC, and then another multiply box for our amplitude envelope. Put our cycle in here, take our envelope from here. This is our VCA right here, right? So our VCA is being controlled by our envelope, and then our cycle is coming in and being scaled by that. So if I go in here, now notice this is going to be a monophonic. I can only play one note at a time. If I try playing the second note, then it's just going to replace the first note, right? Also, if you release a note when you played after you played a second note, sometimes it does something a little bit unexpected. So the easiest way to do this right now is just play one note and release it before going on to the next one. Okay. So to modulate the frequency of our carrier, we need to add something to our frequency that's coming out here. Now to make that life a little bit easier, I'm going to go ahead and make this into a signal. Whoops. By using a sig tilde object. And now we're going to add something to it. All right, there we go. Right now, by default, this is going to be adding 0, so nothing's going to happen right now. We need another operator to modulate this. So we're going to make a modulator, which is going to be a cycle operator. Oops. Another sine wave. And the sine wave is going to have an amplitude. And the sine wave is also going to have a frequency. So I could set this to be like 2 hertz. Nothing really happens because 2 hertz is not very much, right? Just for interest, let's go ahead and monitor the output of this. So you can see that our frequency is going up and down a little bit, but it's only going up and down by a little bit. Let's go make that be 10. Whoops, okay, so what's going on here is this is actually our amplitude is only 0.1. Right? So let's go and make our amplitude of 0.1 actually like an amplitude of 10. Now normally you would never do this, right? Because we normally want a sine wave just go from -1 to 1. Like that's the amplitude if we're listening to it. But in this case, we're not listening to the sine wave. We're using it to modulate the frequency here, right? So if we have a frequency modulation amount of 10, you can see how much the frequency is changing right here. That's audible. You can totally hear that. If I make this only 1, it's basically inaudible. Even though this is still going from -1 to +1, we're not really hearing a change because 1 hertz is not a very significant change. Now, interestingly, 1 hertz is a little bit more of a change when we go to low frequencies. Oh, I'm sorry. Let's set that here, and let's go ahead and make our octave of our keyboard be a little bit lower. So you can tell that there's some pitch modulation there, right? Take it up a couple of octaves. So as you go up the MIDI notes, as you go up octaves, the amount of modulation actually has to change to be perceptible. At a low octave, 2 hertz, actually a 4 hertz swing, right? -1 to 1 multiplied by 2 is actually a -2 to 2. So a 4 hertz swing at a low frequency is perceptible. A 4 hertz swing at a high frequency is basically imperceptible. It's very, very, very subtle. That's actually important because what it suggests is that the amplitude of our output here should actually be scaled somehow by the frequency of either our carrier in some form or another. Well, let's do a couple things. Let's back up. So I've been setting our frequency of our modulator here just by hand, right, to be basically the low frequency oscillator range. Instead of doing that, we actually want to make it so that our frequency of our modulator is an integer multiple of our carrier. Remember, that's what frequency modulation, if the index of modulation is an integer multiple, or if the frequency of the modulator is an integer multiple of the frequency of the carrier, we can guarantee that all of the sidebands will be harmonics, and that's really important. So I'm just going to say, put a floating point multiply object here, and I'm going to make an integer multiplier. So this integer is going to ensure that these are always going to be, integers, which means that the output of this is always going to be an integer multiple of this. And there is our frequency of our modulator. If you go up to A, you can normally see, because A is always going to be a nice round number, that this is 3 times 220, right? Okay. Now the next thing we're going to do is we're going to take that number and we're going to multiply that by something that we're going to call I, which is the index of modulation. And the index of modulation is going to scale this value to generate the depth. So what this means is that with an index of modulation of 1, our cycle tilde is swinging up and down by 1,320 cycles. It's going plus or minus 660, right? Notice that that doesn't sound bad, but it definitely sounds a lot more complicated than a sine wave. That's just a sine wave with the amplitude of our modulator set to 0, right? Because I just scaled it by 0. I'm going to go ahead and take our envelope and move it over here. You know what I'm going to go ahead and do, actually, is I'm going to take all of this envelope and I'm going to encapsulate it. So I'm going to select all of these things, except for the select 0, because that actually is going to be used for a couple of things. I'll go ahead and unselect both of those things. And now I'm going to go up here to Edit, Encapsulate, and I'm going to call this ADSR. All right, so there is everything in here is exactly what we had before, but it's nice and hidden in this little encapsulation. It's nice and organized. All right, so I'm going to bring this down here. I guess we leave it up there for now, but at least it's out of the way. Okay, so let's go ahead and label some of these things. So this is I, right, which is the index of modulation. And this is the harmonicity. Remember, harmonicity is just how much you're scaling the frequency of the carrier by, and it's normally going to be an integer. Harmonicity implying that it's making harmonics. And just with those two values, you can change the timbre of the sound by all sorts of different ways. As you increase I, you're going to be increasing the amplitude of your sidebands. As you increase the harmonicity, you're going to be changing the distribution of the sidebands. Let's go ahead and make a spectroscope so we can see how this works. Let's see, take a look at our carrier. So if I put this up here, oh, you know what? I encapsulated all this, which means that all of these values got forgotten when I did the encapsulation procedure. So I'm going to have to remember all of these values. But let's actually do this. Instead of doing it manually, let's make a preset object. So a preset object is going to take a look at our patch, and it's going to remember all of the values of the user interface objects. So that basically means the harmonicity, the index of modulation, and these 4 values, and also this value actually. It'll remember anything, any number box or dial or slider that it can see in the patch. So shift click to store something, and then press click to recall it. So what that did is it saved all these numbers, and then when I pressed it again, it sent those numbers out. And the reason why it just made a note is because it saved and recalled as 127. So every time I hit this, it's going to set this value to 127 and trigger a node on. It wouldn't have done that if I had saved this number box in here, or if I do this and just send the velocity directly in. Now when this number gets recalled, it doesn't go anywhere, right? So here is our is the output of our FM synth. I'm not going through the envelope here, which is why we're still seeing it. We're just coming straight out of the carrier. And as I increase my index of modulation, notice nothing's going to happen, by the way, until I trigger another note, because this doesn't trigger anything unless the left inlet receives a new value. So notice that with different indexes of modulation, we can really make a very dramatic effect. If you go less than 1, it can be quite subtle. But still very pronounced and very different than just a sine wave, right? Even a little bit of added harmonics will make a nice, pleasing sound. Notice that you can see the sidebands that come up from the fundamental and also the sidebands that bounce off of 0 and get reflected up, right? And also notice that you can kind of see the spacing. You can see here, here's our fundamental, here's our first harmonic or second harmonic. Our third harmonic is missing, right? That's actually what you would expect, right? So if the fundamental is 1, then 1 plus 3 is 4, and 1 minus 3 is 2. So we get 1, 2, and 4, but 3 is missing. If we make our harmonicity 2, we're going to get 1 plus 2 is 3, and 1 minus 2 is 1. And we're, again, not going to get any of the even. We're going to be missing all of the even harmonics and making more like a square wave distribution. Notice, though, that the amplitude of these harmonics is really different than it would be if it was a square wave. You can kind of try to tweak your index of modulation to try to get a square wave-like distribution, but you'll never actually really get there. It's always going to be slightly different. If you want to make something that's like a sawtooth wave where it has all harmonics, you need to set your harmonicity to 1. And then it'll be 1 plus 1 is 2, and then 1 plus 2 times 1 is 3. It'll just keep going up the harmonic series. So practically speaking, most of the time what you're going to do is you're going to just explore and sort of get a sense for what the different harmonicities sound like. And you don't normally change harmonicities while you're playing. You normally set the harmonicity to be fixed. Something that you will very frequently do is modulate the index of modulation with an envelope. Let's go ahead and use our same envelope we already have, but we're going to modulate rather the amplitude of our modulator with our envelope. So right now we're already setting our index of modulation, and we're setting out here. So we basically want to take this value and scale it. There's a couple of different ways you can think about this. So let's think about this. What we want is we want our index to go from, let's say, 1 to 10. Right? So our lowest value for our index wants to be 1. Our highest value for our index wants to be 10. All right? So there's a lot of different ways that you might structure this sort of mathematical operation. You can't just do this. So let's say I go in here, I make sure that this is a signal, and then I multiply this by our ADSR. All right. So what this is going to do, and then I can set this, our index of modulation, to be 10. So what this is going to do is it's going to make it so that our output here is going to go from 0 to 10 and then back to 0. Of course, actually our amount of modulation is a lot higher, right? It's because we're multiplying it by this value. Let's actually, maybe just to sort of see that a little bit differently, let's actually multiply our index of modulation by our amplitude envelope. So notice I'm turning all of these into signals so we can get the multiplication using our audio rate multipliers. Okay. So now we take our index of modulation, we multiply it by our envelope, and then we will scale that by our frequency of our modulator. Let's set that. And you can see it drops down to 0. By the way, notice immediately what an effective what a nice effect that has on the sound. FM sounds so great. It's so versatile and so powerful. And can be really crazy, but it can also be really subtle. Maybe the one thing we don't want to have, though, is we don't want to have this drop down to 0. Then it drops all the way down to being a sine wave at the end of the note. And if it's a longer note than this, like a longer release or a longer or a lower sustain level, you can really hear that. So instead, what I like to do is I like to add the index of modulation. So the index of modulation is the lowest value you get to, and then you add that to a depth of modulation of the amplitude envelope. All right, so here we're going to go in here, make a depth of modulation, and put that in here to add to that. So now this is our base index of modulation, and then this, let's say we make this be 4. Let's go ahead and look at the output of this so we can see what's going on here. You can see that the value is going to go from 6, 4 plus 10, 4 plus 2, and then when this drops down to 0, our base index modulation is still going to be 2. So to get this range of our index going from 1 to 10, we need to make this be 9, and this be 1. And there we get sort of a classic modulation. So we might call this, envelope depth, or envelope amount might be another way of calling that. Okay, whoops. So here we have our FM synthesizer, basically completed. This is going to be fully functional FM synth. It sounds really super flexible. You can do lots of things. You can save presets just by clicking on here and then recalling another preset over there. You can change the attack, decay, and sustain times, and release times. Make another preset. Oof, that's way too much envelope depth for what I have in mind right here. Let's go ahead and do that. People find that for the electric piano sound, the decay sounds like it wants to be like this. Maybe even a little bit longer. And that sustain is a little bit too low. Which is very close to what I had it in the original set of envelope values. Kind of funny. Okay, one last word that we might do here is we might think about a couple things. First of all, we could, instead of using number boxes, use dials. So I could take this dial and I can use this to control, for example, my harmonicity. Now I know I never want my harmonicity to go to 0, and I never want my harmonicity maybe to get above, I don't know, it could be any value you want to actually, but you might find practically speaking that you get to a harmonicity of 10 or 20. And what you're noticing, you're starting to see aliasing, right? Those harmonic peaks kind of in between over here. That'll happen with higher harmonicities or deeper depths of modulations. So getting up to about 20 is definitely, I think, the far end. Well, I don't want to limit you. Do whatever you want to do. Try crazy harmonicities. It's kind of fun to make noise with FM. But I'm going to go ahead and scale the value of this dial. So the dials by default can send out a 0 to 127, like all MIDI objects. 0 to 127 to 1 to, say, 20. And I'm not going to put any periods in here to make sure that we don't do floating point numbers. We only want integers to come out of this because we want our harmonicity to be an integer. Maybe make another dial here for the index of modulation. But I'm going to do something different here. I want this now to be, I'm going to scale this 0 to 127 to 0 to 1. I could just divide by 127, I guess, but that's what I did for now. Okay, now what I'm going to do is I'm going to use an expression object, and I'm going to make that be an exponential value. Pow F1, and then my exponent is going to be 2. And then I'm going to multiply that by 100. I don't know. This might be a crazy idea. Let's see what the result of this is. Now, theoretically, what this exponent is going to do is it's going to make it so that I've got a lot of low values here. So the values aren't really going to change a lot very dramatically in the lower part of this. But as they go to the higher part of the dial, the values are going to rapidly increase, and then they're just going to get nuts. Really big jumps towards this end of the dial, like jumps of 5. Whereas over here we're getting increments that are very small. Let's actually make the exponent be even a little bit higher than that. Say 2.5. Because really we want to focus on index modulations below 10. So this gives us a fair amount of variation here. But then we can also get kind of high. So if I play like this, let's make our harmonicity be something more reasonable, like 3. Classic FM, sounds great. Go all the way up. All of these aliased frequencies are just making like a very metallic kind of sound, which is a lot of fun actually. Really useful for things like cymbals or tuned pipes or metal pipes or kind of making metallic sounds. Let's make our index modulation 1000. We're basically starting to make white noise at this point. But interestingly, it's not quite white noise. It's actually a little bit more nuanced than that, which is actually a lot of fun. I love that sound. Go even further to 10,000. And we really are getting basically white noise at this point. So you can easily get to the white noise part by raking the index modulation really high. But for the most part, we'll probably want to be staying. That's an extremely high index modulation here. So now that I've done this, I can go ahead and make this presentation view of everything. So to do that, what I'm going to do is I'm going to select the objects I want to include. I'm going to select everything that I'm going to interact with. So all of our envelope settings, our harmonicity and our index modulation, as well as the comment boxes, our envelope depth, our preset object. I'm also going to select our spectroscope and our DAC. I'm also going to select this just as a monitor so we can see what's coming from our MLE.midiKey. And let's go ahead and monitor our index modulation as well, just so we can see what's going on there. And our harmonicity as well. Okay, so now, I'm going to go add these to the presentation. I normally do this with a hotkey, adding to the presentation, I believe is an object, add to presentation right here. So I already did that. You can remove it from presentation if you want to. But now that we've added these to the presentation, we click away, you should see that they're highlighted in pink. And if you go to presentation mode, which is right here, everything else gets hidden, and we can move all of these objects however we want to move them. Whoops, I did something weird. I enabled to operate while unlocked mode. I don't want to do that. I don't even know how I did that. Here we go. Okay. Let's go ahead and make index modulation over here. Envelope depth can stay like that, or let's go ahead and move this up above it. And then you can organize these however you want to organize them. I'm not going to spend a lot of time doing that right now. One thing that you might find helpful is that you can, I'd probably also make an output volume control, which I don't have right now. You can make panel objects, and you can use these panel objects to organize things. So for example, you want to have your envelope grouped. You can select the panel object. Now notice it's hiding everything. You have to go to Arrange and Send to Back right here to send that panel object to the back. And now notice you can't see anything here. You can either change the color of the text, or you can change the color of the panel box by going to the inspector. I'm changing my text to be white, and then you can see your decay envelope. When you create an object in presentation mode and you go out of presentation mode, it just ends up in a random place. So I oftentimes try not to create objects in presentation mode. I create them in this mode and then add them to presentation mode so that they're in a reasonable place. Also notice that moving things in presentation mode does not move them not in presentation mode. And that's extremely useful. It's very easy to make user interfaces in Macs that are really well organized and to hide the complexity of your patch behind it. Okay, so that is making an FM synthesizer. The one last thing, the couple additions you might do, let's say you wanted a separate ADSR to control the depth, your index of modulation, then controls your amplitude. All you have to do is just select this stuff, option, click and drag, and then reconnect your note on and note off messages. So make this be your ADSR for your amplitude, and this be your ADSR for your index of modulation. And then you can set these differently, which is very typical to do, by the way. Something else you could do is you could try to encapsulate as much of this as you can, and then you can add more than one modulator. So a classic thing to do in FM synthesis is have 4 operators, 3 or 4 operators, or even up to 6 operators, and arrange those in different configurations. So that's a little bit like the DX7. You can read up a little bit on how the DX7 arranges its operators. And it's very easy to encapsulate most of this, except for your index and envelope depth, index modulation, harmonicity. If you encapsulate everything else, then you can just copy and paste and make lots of operators and connect them in different configurations. And that can be a lot of fun.